Hi, so I wanted to take this lecture where I wanted to deal with the basics of space tech. In this lecture, I will try to keep the things very concise yet comprehensive. And let me tell you one thing very frankly that apart from whatever you do in current affairs in space tech, the basics of space tech plays an important role when it comes to the prelims examination. Okay. Be it the bouncer question or be it one of the option in your what I can say the entire question will be from the basics, right? So before I move ahead, let me request one thing that if you're comfortable in the recorded format, if the things are making sense to you, do let me know in the comment section. And if you wanted the things to be live further, whatever we have left, do let me know in the comment section itself. In the recorded, there is a benefit that you can complete the things at your own pace. You can skip whatever you want to do, and you can cover whatever is left in your preparation wala part. Okay. So let's come to this. First of all, when I talk about space technology, majorly my orientation is towards the launching of a satellite. And when I launch a satellite, sir and ma'am, when I launch a satellite, I launch the satellite through a launch pad which is kept at some launch station. So there will be a launch station, maybe at some particular district. There will be a launch pad which will launch the satellite. Now when we launch a satellite is carried by a launch vehicle. So when you launch the launch vehicle. At the top of the launch vehicle or as a part of the launch vehicle, there is a satellite. Now what is satellite? Satellite is nothing but some different payloads coming together to achieve a desired objective. Do I make sense? Now when we will be dealing with the launch vehicles will be propelled or will accelerate or will move with the help of fuel. That is what we have to read explicitly as a part of the syllabus. And when the things are launched through the launch vehicle, they will be put into some particular orbit. So we have to read the orbits also. So whatever boxes you can see on the screen, this is something we will be dealing as a part of this lecture. Let me come to the orbits. But when I talk about the orbit of a satellite, will be dependent on the speed of the launch vehicle, majorly on the velocity of the launch vehicle and the fuel available with the launch vehicle. Now if I want the satellite to revolve around the earth, I need to send that satellite with a speed more than the escape velocity. If you don't know, this is a part of what I can say the physics which you can definitely ignore. The velocity at which an object revolve around the earth, the velocity at which the object revolve around the earth is under root 2 times gravitational force into mass of earth upon radius. So one thing is very crystal clear from here, that velocity is inversely proportional to inversely proportional to radius of the earth. Why this is important? This is important to understand a simple aspect. Just focus upon this image. Very important, very important. Focus upon this image. If you are if this is clear, you will be able to figure out what is transfer orbits and all those things. See, whenever you send a satellite around the orbit or around the earth, it revolve around the orbit. Now for example, if the satellite let's say has some speed v in this orbit and the distance will be r, what if, understand my point, what if out of some internal measures, I slow down the speed of the satellite? What if I slow down the speed of the satellite when it is reaching here? Will the radius will be increased or will the radius will be decreased? Sorry, will the radius will be decreased? Will this will the case or this? I told you that velocity is 2 times g mass of earth upon r. What I am doing is I am reducing the velocity of the object. If I am reducing the velocity of the object, what is the way out? If you want to reduce this, obviously you have to increase the radius. That means if you are reducing the velocity of the object, sir, your radius will increase, and that is nothing but the elliptical orbit. Understand one thing, what I am saying, the first category of the orbit will be circular orbit, where the velocity is constant around all the places. Distance is equal, it is r from here, r from here. This is nothing but circular orbit. Velocity will remain constant at every point of place in the orbit. There is another category of orbit which is elliptical orbit, In the elliptical orbit, if this is the distance, let's say x, and this is the distance y, where you think the velocity will be more? The velocity will be more when the radius is less. It is inversely proportional. Just keep this in front of you, 2gm r upon r. So if this is small, the entire value of this will be large. That means in this orbit, in this elliptical orbit, whenever the satellite is at this position, the velocity of the satellite will be more, and whenever the satellite is at this position, the velocity of the satellite will be less. What I am trying to make a point is that, you know, the set distance which is at more what I can say, the length, whenever the satellite revolves around it, this position is known as apogee and this position is known as perigee. Perigee matlab pass, I mean that is how I remember, P for perigee, P for pass in Hindi. So perigee is the location where the satellite is at a less distance from the center. So what will be the condition here? Distance is less, velocity of the satellite will be more. And what will the condition here? For more distance, velocity will be less. This is something which I wanted you to know as a basic concept. Now understand one more thing. Apart from the speed, what will be the coverage of the satellite at the lower distance? What will the coverage of the satellite at the higher distance? Or what will be the coverage of the satellite when it is closer to the earth? What will the coverage of the satellite when it is far from the earth? Obviously, if this is closer to the earth, it will be able to cater a smaller area, this one. And whenever it is larger, it will be able to cater the larger piece of area. So whenever it has a more distance, this is speed. And if I talk about coverage, my coverage will be less here, my coverage will be more in the case when the satellite is at more distance from the center of the earth. Next thing which I wanted to follow is the latency. If you remember my science and tech lecture, latency, that time gap in order to receive the signal back. What will be the situation in both the cases in terms of latency? Understand one thing, if the satellite is near to the earth, my latency will decrease, sir and ma'am. It will take less time for the signal to travel and come back. And when the satellite is far, at more distance from the earth, my latency will be high. So these are the basic things which I wanted to follow. Based upon the distance, less distance pe speed will be high, coverage will be less, latency will be less, there will be less time gap, so better signal. So if I want to convert this into signal, it will be better than this, in case of less distance, low latency, better signal. Okay, so this is the first basic thing which I wanted to know. Now understand, if this is the earth, you can place satellites in different orbits, right, based upon the requirement. Now your requirement could be that you need some better signals or you need lower latency, but you need what I can say, moderate coverage. Now your requirement could be you need very high coverage, but your latency could be high, no issues. So in all those circumstances, we have different orbits on the earth, different levels of orbits around the earth. The lowermost orbit is known as low Earth orbit, the medium Earth orbit, and this is geo Earth orbit, geostationary, geosynchronous orbit. Then beyond this, we have higher Earth orbit. So there will be some distance of this, there will be some distance of this, there will be some distance of this, and there will be some distance of this also from the Earth. First of all, whenever you're looking at the orbits, beta, first thing, just be mindful of the average distances in which orbits are lying. Secondly, please see the types of satellites or types of use case of these orbits, where we can insert the communication satellites, where we will generally insert the remote sensing satellites, where we will be inserting the navigation satellites. Now what are different category of satellites? I'm coming to it. What I am saying, I should be mindful of the types or the use case of these orbits apart from distance. Then I should be more concerned about the types of orbits. So you might have seen in your maybe various test series, maybe geostationary, geosynchronous, sun synchronous, polar orbit, etc, etc. So what are various types of orbit? That is what we'll be focusing upon. But before coming to orbit, again I will take you back to the satellites or the types of satellites. Just focus upon this slide now. See, first category of satellite is communication satellite. Communication satellite, where we send the signal, we receive the signal, there is a transporter, there is a receiver, and that is generally used for the, let's say, broadcasting wala thing or the telecommunication wala thing. Okay. Now in this, generally we need a very large coverage, because we cannot put multiple satellites for, let's say, a single broadcast. We want that a broadcast may be what I can say, maybe sent a little with a little delay, थोड़ा देरी से जाए, but बहुत सारे लोगों को जाए. ठीक है. So for the broadcast purposes, for the telecommunication purposes, generally communication satellites are placed in the geostationary orbit. Do I make sense? Why? Because we need more coverage. Now there is a second category of satellites, which are Earth observation satellite. Earth observation, the main role of these satellites is to observe the Earth. Now when you observe the Earth, what you will observe? Either you will observe the weather, or maybe the climatic conditions, or maybe the temperatures, or maybe the oceans, or maybe the forest, or maybe the what I can say, the environment, or maybe the resources. That is what you observe on the Earth. Now when this observation thing is being done, you want things to be very precisely looked into. Okay. You don't want the fade images, you don't want the things to be with a very much delay. So generally, first of all, these Earth observation satellites are of two categories. First is weather monitoring, where you want to monitor the weather, maybe the rain, maybe etc, all those things, weather monitoring. Second is remote sensing, where you want to sense the resources of the Earth, forest, etc, oceans, all those things. You want to see the condition of the resources, and if you want to observe the condition of the resources, you need things to be very much clear. Okay. And that is where, whenever the remote sensing is there, you need to put the satellites in the lower Earth orbit. So it was in geo Earth orbit, this is in lower Earth orbit. Now the question should be there in your head, sir, why only in lower Earth orbit? I'm saying this is not only in lower Earth orbit, majorly in lower Earth orbit. So if the question is coming in the examination that only in lower Earth orbit, that is wrong. Remote sensing satellites can be placed in medium Earth orbit or maybe in geostationary Earth orbit, but then the accuracy will decrease, visibility will decrease. Okay, and the latency will increase. So remote sensing satellites are majorly placed in the lower Earth orbit, to which polar Earth orbit is one of the components. So when we divide the lower Earth orbit, we divide into two parts. I will come to it, don't worry. First is polar Earth orbit, second is sun synchronous orbit. ठीक है, आप बस ऐसा समझिए कि remote sensing satellites are majorly placed in lower Earth orbit, that is polar Earth orbit, or one of them is polar Earth orbit. Weather monitoring satellites, since again they will need a more coverage, है ना, of the entire weather of the region, so they are generally placed in the geostationary Earth orbit. Then we have the navigation satellite. Now when I talk about the navigation satellites, sir and ma'am, what is the function of the navigation satellite? Have you ever used the Google Maps or the GPS? The same function, okay? So they need to send you the location and all those things. You need to send your location to the satellite, then they will give you the route and all those things. So navigation satellite may first of all the accuracy thing should be monitored, latency thing should be what I can say, the moderate, and at the same time you don't need many satellites, right? You need moderate number of satellites. Now what will happen in navigation satellite, we are generally putting these satellites into the medium earth orbit. If you will see the GPS system of USA, the satellites are placed in the medium earth orbit. But can or should we place the satellites only in the medium earth orbit? The answer is no. I will tell you that India's navigation system, we have placed our satellites in the geostationary orbit or maybe geo-sun synchronous orbit. Okay, what I'm trying to make a point is medium earth orbit is preferred, but we cannot only put in the medium earth orbit. India is placing its navigation satellites in the geostationary orbit, 4 of them, and 3 of them in geo-sun synchronous orbit or geosynchronous orbit. Okay. Now beta, astronomical satellites. If you have done the astronomy with me, you know what do I mean by astronomy. When I talk about astronomy, it's all about stars, universe, black hole systems, merger of stars, dark matter, dark energy, etc, etc. So the major role of these satellites will be to study the electromagnetic spectrum. If you remember the entire electromagnetic spectrum, okay? So astronomical satellites can be placed in any of the orbit, but majorly they are placed in high earth orbits, so that they can be out from the interference and they can study the universe much more better. So they are not majorly for the earth, they are for the other things, maybe the star system or the universe system. So they are generally placed out of the earth, what against the interference, and hence generally in the higher earth orbits. Okay, so I think this is clear. Let's come back to this orbit, but before that, let me talk about the launch pad and the launch stations. You have to just remember 3 of them. First is Vikram Sarabhai Space Center. So this is a launch station located at Thiruvananthapuram, Kerala. So if you don't know, the UPSC may anytime ask them in the match of the following, etc, etc. So you should know that Vikram Sarabhai Space Center is located at Thiruvananthapuram, Kerala. Satish Dhawan Space Center is at Sriharikota, Andhra Pradesh. So from SNS you can remember this. Then Dr. Abdul Kalam Island, again a launch station of India, is located at Bhadrak, Odisha. So I want you to remember 3 of them and a basic information which we will see later. Abhi darna mat, padhaunga isko pura. New generation launch vehicle right now which is under development, new generation launch vehicle, we will see in the launch vehicles, right? This is being developed around Satish Dhawan Space Center. So whenever it will be ready, Satish Dhawan Space Center will be used to launch the NGLV, new generation launch vehicle. So that was about the satellite, that was about the launch pad. Let's get back to the orbit. So in orbit we realize that whenever the distance is less, speed will be more, coverage will be less, latency will be less, matlab better signals will be there. But what if I want to cover the entire earth? What if I want to cover the entire earth? Since the coverage of a single satellite is decreasing, understand, since the coverage of a single satellite is decreasing, don't you need multiple satellites to cover the entire earth? If it is in a lower orbit or if it is a lesser height, you need more number of satellites, and if it is a much higher height, you need less number of satellites. So that means if they want to cover the less distance satellites, see, do not remember it with the lower earth or medium earth or geo, just simple thing, less distance, more number of satellites, more distance, less number of satellites, khatam. So this will need more number of satellites, and this will need less number of satellites. Now when I talk about the distances, I have told you, first of all, we have divided the things into low earth orbit, medium earth orbit, and geo earth orbit, further divided into sub classification. I will come to that. First focus here, low earth orbit. First of all, I told you we have to see the distance of the orbit. The distance of the low Earth orbit is around 160 to 2000 kilometer. Now it could vary in various textbooks, doesn't matter, आप बस 1000 किलोमीटर के हिसाब से याद रखो, 800 से 1000 किलोमीटर, ठीक है. For you, low Earth orbit is around 800 to 1000 kilometer. What will happen? First of all, if you want to cover the entire Earth, if the satellite is placed in the low Earth orbit, how many number of satellites will you will need? You will need more number of satellites compared to above orbits. Coverage will obviously decrease compared to above orbits. Speed will increase compared to above orbits. That means a satellite placed in the low Earth orbit will complete the round in less amount of time. ठीक है? A satellite placed in low Earth orbit will complete the entire round in less amount of time. So the time of covering the entire round around the Earth will decrease, and approximately it is 2 hours or 1.5 hours to cover the entire Earth. And what about latency? Latency will decrease, okay, in the low Earth orbit. Now, when I talk about low Earth orbit, remote sensing satellites are placed in low Earth orbit. ये मैंने आपको बताया था, because they want to sense things or they want to have a better view of the resources. ठीक है? So they are generally placed in the low Earth orbit. Then we have the International Space Station. This is also placed in the low Earth orbit just for a simple reason that if anything happens, or if you want to send something, you want to bring something, you want to, what I can say, service the International Space Stations, it is more easy for us to do that. So International Space Stations are also placed in the low Earth orbit. Then some of the communication satellites are also placed in the low Earth orbit. And if you wish, you can pause the video and tell me an example of it. Starlink. Right now, if you followed my earlier sessions of RRR, I told you that the communication satellites in the geostationary orbit have higher latency. Although they have a higher coverage, but there is a lag in the signal. So what this Elon Musk is doing, or what other people are also doing, they are placing the satellites in the low Earth orbit so that the latency decrease, speed increase. Are you getting my point? So if the question is asking in the examination that communication satellites are only placed in geostationary orbit, false. It could be placed in the low Earth orbit. We have the example of Starlink with us. Okay. Now the low Earth orbit are further divided into two orbits: polar orbit and sun synchronous polar orbit. First we will see the polar orbit. So polar orbit is a type of low Earth orbit, almost circular. So it is around the pole. If this is the Earth, these orbits are like this, around the pole. Now it could be at some inclination also. So if the question is coming in the examination that it is exactly at the 90 degree from the equator, false. It could be at some small inclination from the polar region, right? So that it is able to cover the entire Earth. Because the काम ही remote sensing है ना. So low Earth orbit, almost circular orbits are there, and it is used in remote sensing. Now, sun synchronous polar orbit is another subcategory of lower Earth orbit. Now, what is the specialty of this? This you will not forget that it is in fixed position with respect to sun. So the satellites are placed in such a fashion that at the same point of time, it will be at the same spot again, first of all, and it will be in synchronization with sun. If you wish, you can see a video on the YouTube. The things will be more clear. ठीक है? अगर बहुत ज़्यादा confusion है, the sun synchronous polar orbit demonstration. Just put it on the YouTube. You will see the demonstration. Okay. So it is in fixed position with respect to sun. Then satellite visits same spot at the same time. It will visit same spot at the same time. It is, let's say, at Delhi at 1 p.m. So on daily basis at 1 p.m. it will be over Delhi only. On daily basis. So it will be at the same spot at the same time every day. Then the next and very important quality. See one of the video if you wish to do, or maybe any image on the YouTube. I don't have that time right now with me. I need to go quick. So this sun synchronous orbit has constant sunlight ka what I can say, the phenomena. So they always get the sunlight because they are in sync with the sun. So they have the constant sunlight whenever they are in the orbit. Wherever the sun is going, they are going along with the sun. है ना? So that is how sun synchronous orbit have the constant access to the satellite. So first thing, always in fixed position relative to sun, satellite with the same spot at same time, and it is having constant sunlight as well. Now we are done with the low earth orbit. What you can do, pause the video, look at all the points, and please conceptual soundness in space tech do make sense for your other current affairs also. Okay, you will realize it by the end of the lecture, है ना? Medium earth orbit, generally the distance is 2000 to 35786. Why this particular number? Why this particular number? Understand one thing. Understand one thing. We all know that if the satellite is closer to the earth, time is less. It is just revolving around the earth maybe in 2 hours maximum. As the distance increases, it will be 3 hours. Further distance maybe 5 hours. More distance will be maybe, let's say, 8 hours. There will be some distance in the orbit. There will be some particular distance in the orbit when this time will be exactly equals to 24 hours. That is, when the earth is making a complete round, satellite is also making a complete round. The time is equal with the sun's earth's time of revolution or rotation. Okay, chalo. So what I am trying to make a point is, this is that distance of the orbit where if the earth is completing a single round, satellite will also complete a single round in 24 hours only. So until this distance, below anything to this distance is nothing but medium earth orbit. And first of all, the time of one what I can say, the revolution around the earth, first of all, it is lower than 24 hours. Does this make sense to you? Obviously, because after 35786 it will be more than 24 hours, and at 35786 it is exactly 24 hours. Okay, so before, in low earth orbit, the time will be less than 24 hours. First thing. Second thing is the types of satellites which are placed in this orbit. First is navigation satellite, because they need a balance between the coverage and the signals. Okay, then earth observation satellites are also placed here, some of them, weather monitoring, etc, etc. Then some of the communication satellites are also placed here. The only thing which you will remember is navigation satellites are majorly placed in medium earth orbit. GPS is placed in medium orbit, and there is an exception of India, IRNSS. So our navigation system is placed in the geostationary orbit. What is the reason? That we need less number of satellites to cover the entire earth. That is the only rationality. Okay? So GPS is placed at 20,200 km of USA. So it is placed at 20,200 km. And our IRNS, मैं बार बार यही बात बोल रहा हूँ, it is not in the medium earth orbit, it is in the geo earth orbits. So 7 satellites का there is a system. 4 of them is in geostationary earth orbit, and 3 of them are in geostationary synchronous orbit, geostationary sun synchronous orbit. Okay. Now what is the difference between these three? See, if you will see, geo earth orbit is nothing but the orbit of exactly 35786 kilometer. Exactly 35786 kilometer. This is that place or that distance at which earth rotation time and the satellite pura entire time of revolution is same. It is same. But again there is further sub classification. First is geostationary earth orbit. So geostationary orbit or geostationary earth orbit, the distance for these two will remain the same. See what is happening. I just want to show you the different types. What is happening? This is the earth, this is the satellite. Now if this satellite is revolving with the earth on its axis, equatorial axis only, so what will happen? Earth is also revolving like this, satellite is revolving along with the earth only on the equatorial axis. This is nothing but geostationary orbit if satellite is here. But let's say if earth is revolving like this, but the satellite is revolving like this, in any other plane other than the plane of the earth of rotation, although it will complete one round only in 24 hours. But don't you think it is again in sync with the sun? It will be at the same point at the same time again, because the rotation time is 24 hours. So if it is rotating around the earth in 24 hours, earth is also it is revolving around the earth in 24 hours, earth is also rotating in 24 hours. So it will be always at the same point at the same time, and it will be in sync with the sun also. So that is where these satellites in yellow, these are geosynchronous orbits, and the satellite in the orbit in white is nothing but geostationary earth orbit. Okay. So these are two categories of orbits. Now let's come to the third category, geotransfer orbit, and let me tell you from my what I can say, the sense of examination, this is more important than the other two. Geotransfer orbit, understand this very carefully. Geotransfer orbits बहुत अच्छे से समझना. See, this is the earth. Let me say this is either this is one of the geosynchronous orbit. Let's say this is geosynchronous orbit. I want to send my satellite to the geosynchronous orbit. Now the length of the, or the height of the orbit is around 35786 kilometer. Don't you think I need a decent speed and a good amount of fuel to send my satellite to this orbit? So this is at a higher height, I need more fuel. Simple. What if instead of doing this, I send my satellite to this orbit, sorry, to this orbit, and then whenever the satellite is here, I will keep on decreasing the speed of the satellite. Let's say this orbit is somewhere 20,000 kilometer, let's say 20,000 kilometer, but whenever my satellite is coming here, I'm decreasing the speed. What will happen? Whenever I'm decreasing the speed, the satellite will be forced to move ahead. If you remember, speed will come down, radius will increase. So my satellite will be now forced to move ahead, and this will be the new position of the satellite. And again, I will decrease the speed. When the satellite is coming at the same position, I will decrease the speed again, and my satellite will be in this orbit finally. What I'm trying to do is, I'm trying to save my fuel. And ISRO has achieved so many missions with the same geotransfer orbit. And let me tell you one thing, all our launch vehicles so far are putting the satellites in geotransfer orbits so that we can save some fuel. Then we will use the what I can say, the speed of the satellite, we can use the control system of the satellites to push the satellite in the further higher orbit. So what we are doing, we are placing the satellites in the transfer orbits, and then we are decreasing the speed slowly to push them in the geosynchronous orbits finally. So I hope I make myself clear. Just remember one thing, our GSLVs, our PSLVs, all of them are putting the satellites in the transfer orbits first. Then they are monitored or maneuvered to shift to the stationary orbits, or maybe the synchronous orbits. Hardly matters, है ना? Only the inclination changes. Okay, let's move forward. So we have seen the orbits now, right? Satellite is done, types of satellite, types of, or the launch stations are done. We have seen the orbits. Now we will come to the launch vehicle. But let me tell you one thing, launch vehicle se pehle we need to study the fuels, because fuels along with oxidizer is nothing but a propellant in the launch vehicle. See, if you want to uplift the launch vehicle, you need some basic thrust, and thrust will be generated by the fuel, and fuel will be ignited by the oxidizer. Now if you are in the let's say advanced of preparation of the UPSC, you should know all of the types of fuels. So I will just brief all the types of fuel. First category of fuel is solid fuel. Now what are the characteristics of the solid fuel? I will keep it very brief. Solid fuel give very good thrust, and majorly in all the, what I can say, the PSLV or maybe SLV or maybe GSLV, you'll find that the very first stage of the rocket is the solid stage, so that we can get a very good thrust to uplift the satellite. Okay, from the ground we need a very good thrust. So solid fuels have a very good thrust over the liquid fuels. First thing, if there is a statement, it is true, but it cannot be stopped once started. Or if you're burning anything which is solid, you don't have control over it. It will stop only if it is completely burnt, right? And that is why this is the first stage also, so that we, in first stage, we don't need any control. We want the satellite to reach a certain height, so that is where we use the solid stage generally in the first stage of all the launch vehicles type. So there is a poor control on the solid stage. Okay, then there is a liquid stage or liquid category of fuels or liquid category of engines. Beta, liquid will have lower thrust as compared to solid, but a better energy density. What do I mean by energy density? Is for per kg how much energy I am generating. Okay, thrust is low, but the density or the energy production per kg is generally higher. But easy control is there. The control of liquid fuels are much easy. Whenever you want to shut down, just block the, what I can say, the passing of the fuel, right, or the liquid. Just shut off the shutter, then you will be able to control the, what I can say, the reaction. And if you are able to control the reaction, you will be able to control the liquid fuel engine. So in India, we have already developed the liquid fuel engine, and the name of that particular engine is Vikas engine. I have seen many of the aspirants, they don't even know that Vikas engine is about the fuel or the liquid engine. Okay, Vikas has nothing to do with the solid or the cryogenic stage. Vikas engine is the name given to our liquid stage engine. Okay, this we will not forget from now. Vikas, word Vikas. Then one thing I want you to remember is the liquid propulsion space centers. In India, we have two LPSCs, important LPSCs. First in Trivandrum, Kerala. Second in Bangalore, Karnataka, which are responsible not only for the liquid propulsion system or the liquid fuel system, but also for the cryogenic systems. Hence, the mapping portion of this is important from the एग्जाम पॉइंट ऑफ व्यू. तो आप ये नहीं बोलेंगे कि त्रिवेंद्रम केरला और बेंगलोर कर्नाटक में लिक्विड प्रोपोर्शनल स्पेस सेंटर्स हैं. ठीक है. Then the third type of fuel is cryogenic. What do I mean by cryogenic? First of all, cryogenic engines, lower temperatures पे fuels are stored. Okay, so when at very low temperatures fuels are stored and ignited, the efficiency is ultra beautiful. They have very good efficiency and hence very good thrust. Now the question should come in your head, do we have the cryogenic engine? Let me tell you, around 2017 in India, we made our indigenous cryogenic stage. Indigenous, around 2017, please remember the name, right? So India joined 5 other countries with this capability, and UPSC may any day ask you this, that along with India, UPSC asked this, if I remember correctly, in the question of defense, where UPSC made the question on the scramjet engine, that India has made this technology along with, maybe I think there were Russia and France, or maybe Russia and US. So this is how the UPSC can frame the options again. You should remember, see, these 3 are obvious: US, China, Russia. These 3 are obvious, ki US, China, Russia. Other 2 countries are France and Japan. Okay? So US, China, Russia, Japan, France and India has joined them in order to make the indigenous cryogenic stage. Okay. Now there is another stage, semi-cryogenic. Understand one thing, and this is important for this year, mark it 2 star. सेमी क्रायोजेनिक, ये भूलने की गलती मत करना इस साल के लिए, मैं बता रहा हूँ फिर से आपको. क्रायोजेनिक पढ़ के चले जाओगे, सेमी क्रायोजेनिक नहीं पता तो दिक्कत होगी बेटा. क्रायोजेनिक इंजन में we have to store the fuel at the very low temperature, very low temperature, and that was creating a problem in handling of the fuel. You have to maintain the temperature, right? And that is nothing but a handling issue. So again, the researchers invested themselves and they realized that we can move to something semi cryogenic, in which the fuel will not be at the very low temperature, but the oxidizer will be at very low temperature. Semi cryogenic fuel is not at the very low temperature, so it is the normal temperature. Fuel is at the normal temperature, but the oxidizer is at the very low temperature. Now if you want to go next level in this, okay, और अच्छे से आपको तैयार करना है, तो please look at the fuels which are being used currently in these systems. I want you to remember at least two, and those are: in semi cryogenic we are using the refined kerosene and liquid oxygen, this at cryo temperature, very low temperature, this at room temperature. Okay, this you will remember in semi cryogenic engine, that we are able to handle the things more effectively or more easily, है ना. Now this semi cryogenic engine, acha, I want to tell you one thing more, that we are investing in new generation launch vehicle. So in new generation launch vehicle, this semi cryogenic engine will be at the very first stage. So I'm coming to the types of launch vehicles, where I will be dealing with the new generation launch vehicle. Okay. So just remember, semi cryogenic we are developing for the new generation launch vehicle, upgraded version of GSLV 3. Okay. Then I want you to remember, in cryogenic we are using liquid hydrogen and liquid oxygen stored at very low temperature. Okay, both of them are very low temperature. Here this is only at very low temperature. Sorry, this is only at very low temperature, and this is at the room temperature. Refined kerosene. You will also remember that in liquid we are using UDH, unsymmetrical dimethyl hydrogen, along with N2O4. Just do not remember this. Okay, sometimes these fuels are used here also, but ignore. Just remember, UDH and N2O4 is there in the liquid stage, and hydroxyl terminated polybutadiene with N2O4 is there in solid stage. These two are not important, you can ignore safely if you want to do, but please remember these two. In cryogenic, liquid hydrogen along with liquid oxygen is stored at very low temperature. In semi cryogenic, refined kerosene along with liquid oxygen are there. Okay, chalo. Now what will happen? These fuel will be used in, so we have done this, fuels and engines. Now these will be propelling launch vehicles. So my last agenda with you is launch vehicles. So see what will happen. The same thing, the same fuel will be a part of the launch vehicle, and will be defining the type of launch vehicle. So first generation launch vehicle we had in India was the SLVs in 1970s. So satellite launch vehicle, just remember the name SLV, satellite launch vehicle. Although this is not functional as of now. We do not use them from now. Okay, so solid satellite launch vehicle 1970s, capacity was to take 40 kgs up to 400 km. Not important, do not remember this. Okay, just remember, since this was small payload until the small height was the capability. Then 4 stages, this is something which you can keep in your head, easy to think, easy to remember, that there are 4 stages, and all these stages were solid. S, solid fuel. So what will happen? The satellite will be divided into, let's say, 4 stages. This will be moved out, then this will be ignited, this will be moved out, stage 3 moved out, stage 4 moved out. Then ultimately the payload will be put into the orbit. Similarly, we have the ASLV, augmented satellite launch vehicle, second generation, 150 kgs. The weight was increased in the low Earth orbit. 5 stages were there, all were solid. So if in the prelims UPSC की अगर बुद्धि थोड़ी वैसे होती है और पूछ लेता है यार, augmented space launch vehicle for having all the stages solid, right है, ठीक है. PSLV were the very first launch vehicles, polar satellite launch vehicles, or the very first launch vehicles where we have any of the liquid stage. See, it was 4 stage, SLSL, solid liquid. You will remember the stages and the fuel type, SLSL. Okay, 4 stages, solid liquid, and this was the 3rd generation. Now since UPSC asked the generation in fighter aircrafts or those I think helicopters etc, जो भी अभी लास्ट प्रीलिम्स में आया था, 5th generation कौन कौन से हैं, तो same variety के लिए I have written the generation of the launch vehicle. So this is 3rd, this is 4th. fourth generation. So PSLV 1994 पे we started. The capacity is around 1500 kgs in the polar orbit and around 1200 or 1400 kgs in the sub-geo transfer orbits. So it will not put again into the this geostationary Earth orbit. No, in transfer orbit. And it is a four-stage mechanism. Now, I want you to keep your attention on one thing: poem. Poem. PSLV orbited experimental module. Please give focus to this. UPSC शायद अगर करंट अफेयर्स का क्वेश्चन पूछेगा PSLV से तो इससे पूछेगा. PSLV orbital experimental module. What is happening? Understand that whenever the last stage, this, whenever the last stage is there of any satellite, then the satellite is about to reach to the orbit. But what is happening? You are discarding the last stage. You are not using the last stage at all. So what ISRO has done, ISRO is now sending some of the, what I can say, the peripheral satellites, maybe of some private institutions or maybe of some research organizations, into this fourth stage, PS4. So ISRO is augmenting some of the additional satellites with this fourth stage, so that whenever this fourth stage is detached, whenever the fourth stage is detached from the entire launch vehicle, that fourth stage, when detached, is carrying some of the payloads, maybe of the private sector or maybe from the research organization, which is not the exact, what I can say, not the real objective of the launch vehicle, so that we can utilize the fourth stage also in the experimental format. So this is nothing but PSLV orbital experimental module, where the fourth stage, when detached, is carrying some other satellite by the private sector or maybe by the research organization for the additional objectives, peripheral objectives. That is it. Chalo. So PSLV was used in Chandrayaan 1 C1 and Mars orbital mission. Not that important. More than 50 flights has been there, and it is also known as workhouse of ISRO. So if the question is coming, let's say GSLV is workhouse of ISRO. Generally PSLV is workhorse of, not house, horse of ISRO. Okay. Now let's come to the GSLV. GSLV fourth generation. It is an see, if I talk about the evolution of the GSLV, we started using the GSLV in 2001 or 2000 something. Okay. But we failed because we were not having the expertise, first of all, in the cryogenic stage, and we were not having indigenous cryogenic stage. We used to take the cryogenic engines or the cryogenic stage from Russia, right? So we were not that successful when we started the GSLV. But with time, India developed its own cryogenic stage or cryogenic engine, I will say, and India used its own cryogenic engine from 2017 onwards, and that is where the success story of GSLV starts. Okay, so that is why I have left it in the question mark, that 2000 was a line, but 2017 say, when we have the indigenous cryogenic stage, make the more sense of the GSLV. So if you know, we saw these fuels. So this was in this was in a satellite launch vehicle, augmented satellite launch vehicle, all solid. Then we have solid liquid in PSLV. Then we have in GSLV 3 stages: solid, liquid, cryogenic. That is it. Okay. But some additional strap-on motors will be invented. For example, if you can see on the side, these are motors to give the extra thrust to the engine, strap-on motors. Okay. Then it will be nothing but the third generation GSLV Mark 3. We'll come to it. First of all, 3 stages are there: solid, liquid and cryogenic. Cryogenic is the last stage, solid is the first stage, liquid is the middle stage. Capacity is around 2.5 to 4 tons when it was in the first generation itself, 2000 or 2010 or 2015 की बात हम कर रहे हैं. Then the capacity was less, but with time we have increased the capacity with the help of other strap-on motors, etc., etc. Right? So right now we have the third version of GSLV, which is also known as LVM3. So if in option you get LVM3 directly, that is the official name now, okay, of GSLV Mark 3. We have evolved the versions. Right now we are at the version of Mark 3, which is also known as LMV Mark 3, using indigenous cryogenic stage. It used indigenous cryogenic stage, and this was used for the Chandrayaan 3. So that is it for the SLV, ASLV, PSLV and GSLV. Now let me come to the last part of the story. We have evolved and we are evolving more. The first evolution which we are doing is Surya rocket. or new generation launch vehicle. I told you that we are trying to enhance the capacity of the launch vehicles by playing with the stages of the what I can say the launch. Now since solid stage is having less amount of what I can say the burning time, jaldi khatam ho jata hai, and energy density is also poor. What we are trying to do is we are trying to replace the solid stage with the, remember, remember, not cryogenic stage, solid stage, this stage with the semi cryogenic engine, where we'll be using the refined kerosene and liquid oxygen. So this will be a three stage: semi cryogenic, then liquid, then cryogenic, and the payload weight will be around 3 times, and cost will also increase. It will be around 1.5 times the initial cost. Okay, so if you see Surya rocket or if you see new generation launch vehicle in the examination, please remember this class. Then we have the next innovation, that whenever we are sending the launch vehicles, generally they are not, nothing is coming back, right? They are destroyed between the space only. What if we are able to bring them back? If we are able to bring them back, we will be able to reuse it, वापस से use कर पाएंगे, and if we are able to use it, cost will be low. So what we are doing, sir and ma'am, we are investing in the reusable launch vehicles, and India's first reusable launch vehicle is Pushpak, first vehicle which is tested also. Okay, so what happened, some aircraft took it at the height of, let's say, some kilometers, 4 or 5 kilometers, then it dropped that particular launch vehicle for to see the landing, that whether it is able to land safely or not, whether we can maneuver it or not. Okay, and we were successful in that. So we dropped at a very small height and we are successful to test this Pushpak or relaunch vehicle. Then you have to remember one thing, one extra information of Falcon 9. What is Falcon 9? Falcon 9 is nothing but the relaunch vehicle by SpaceX, and it is world's first orbital class relaunch vehicle. So we just drop the thing from the, let's say, 5 kilometer distance. It will take it to the orbit and will bring back things from the orbit. So it is a real workable launch vehicle as of now. Falcon 9 by SpaceX, and this is world's first orbital class relaunch vehicle. Okay. Then let's come to the last one. I don't know whether it is visible to you or not. Small satellite launch vehicle. So this is a 3-stage satellite. Up see, there is a difference between satellite launch vehicle and small satellite launch vehicle. Understand? When ISRO wanted to send any of the small satellite or maybe any of the satellite in the low orbit, ISRO cannot use the PSLV or the GSLV. It will be waste of resources. Okay? Because if this has to be used, something of 14 or 1500 kg should be sent to the space. But if you want to send just 40 kg or maybe 50 kg, and that too in the 300 kilometer orbit or maybe 500 400 kilometer orbit, that means we should optimize things by not using PSLV or GSLV. So we abandoned these, but we started a small satellite launch vehicle just for the very small satellites, 500 kgs at low Earth orbit, or maybe of not this volume, 1500 5 up to 500. If you want to send anything, we are using a small satellite launch vehicle. This is a 3-stage. Do not forget, UPSC kahin bhi question पूछ सकता है बेटा. I have covered everything for you. This is the 3-stage. First, and all the 3 stages are solid. Okay, this is working. You won't believe me. Almost every week we have a launch of SSLV. That's the frequency of satellites we are sending in the space. Almost every week we are using SSLVs, or ISRO is using SSLV. Okay. Chalo. So let's come to the current affairs now. If you remember my old lectures, I've already covered the space missions, telescopes and missions. I will show you the screen, like the PPTs. But before coming to it, I want to discuss 2 miscellaneous things from which I am expecting the question this year. First is satellite phones. See, generally UPSC has the tendency, if we are talking about the what I can say, the internet directly from the satellite, or maybe if we are talking about the Starlink, UPSC will go peripheral, and UPSC will ask you the question from the same looking thing, and that is why satellite phone is something from which I am expecting a question. What are satellite phones? very simple, very plain. From the name only you can decode. These are the phones which are directly connected with the satellite. Generally what happens when you receive a signal in your phone na sir, that is not from the satellite, that is from the tower. सुना होगा ना, इतने सारे टावर लगे हुए हैं और इस टावर से सिग्नल आएगा किसी लेट्स से अगर मैं पहाड़ी रीजन की बात करूँ तो वहाँ पे सिग्नल क्यों नहीं आते, क्योंकि टावर नहीं होता. अब या लेट्स से लेस नंबर ऑफ टावर होते हैं पहाड़ी रीजन में. तो वो मैं क्या बोलना चाह रहा हूँ, अगर मैं टावर्स को ही एलिमिनेट कर दूं, if I want signals directly from the satellite, or if it is possible to get the signal directly from the satellite, that means I can use the satellite in isolated areas, or I can use the phones in the isolated areas. Let's say if there is a disaster at some place, towers हट गए उखड़ गए, so there will not be any connectivity disruption. So satellite phones are there, although less in number. They are working and they can work without terrestrial antennas, so we don't need the land antennas, and they are connected to the satellite directly. So these three things you will not forget. Then we have the sounding rockets, so you should not confuse what are the sounding rockets. These are the rockets, आपने देखा होगा बचपन में ना, एक white space में हो जाता था, लाइन सी बन जाती थी. So those rockets which are at very lower height just to assess the weather around, those are nothing but the sounding rockets. ठीक है. Although we will deal much about it or about the rockets more in the defense wala lecture which I will take, but you need to tell me in the description beta that whether you want it recorded or live. समझ में आ रहा है तो एकदम चिल है, नहीं समझ में आ रहा तो मुझे बताओ, समझ में आ रहा है तो भी बताओ कि सर यार रिकॉर्डेड कंटिन्यू करो, नहीं समझ में आ रहा तो बताओ कि सर यार लाइव ले लो. ठीक है. तो अपर एटमॉस्फेरिक एक्सप्लोरेशन में दे आर यूज्ड, दे हैव द सॉलिड प्रोपेलेंट, एंड रोहिणी सीरीज समथिंग विच यू विल नॉट फॉरगेट इज अबाउट द साउंडिंग रॉकेट. ठीक है. रोहिणी सीरीज रिलेटेड टू साउंडिंग रॉकेट. फाइन. नाउ स्पेस मिशंस में वी हैव कवर्ड द टेलीस्कोप्स. All these things we have already covered. We have seen the missions, the bodies and all those things in my previous lectures. What is the objective, which let's say is it ISRO, is it NASA, is it Europe, is it other countries. So we have seen almost all of them, and we have seen them what I can say, the planet wise majorly, right? And if you remember, I gave you the homework to do the ISRO related missions and the private missions. So that was the homework. Okay, so this we have already covered. Now I'm left with this thing. Sorry. Feb to April का current affairs. ठीक है. I will just show you the PDF. I made it very what I can say, the concise for you. हमने सब देख रखा है, सब समझ में भी आएगा आपको. 3 पेज हैं बस, ये कर लेना. ब्रीफ में दे दे रहा हूँ. आर्यभट्ट, सिंस 50 साल हो गए यूपीएससी कैन फ्रेम अ क्वेश्चन, लॉन्च इन 1975. थोड़ा पढ़ लेना आर्यभट्ट सैटेलाइट के बारे में. ठीक है. देन वी हैव पार्कर सोलर प्रो, नासा के लिए है, सन के लिए है, नासा से है, सन के लिए. ठीक है. ओके. देन यू हैव पंच मिशन. पंच इज बाय अगेन बाय नासा फॉर सन्स कोरोना, द आउटर सरफेस. ठीक है. Then we have Axiom mission. So Axiom mission is nothing but we are sending someone to the International Space Station. So Axiom mission 4 not important, but एक बार read मार लेना. Then this is a navigation satellite. I told you in IR and SS we have 7 satellites. कहीं लिखा होगा इधर ही. Out of which 4 are in, चलो नहीं लिखा, कोई बात नहीं. 4 are in geostationary orbit and 3 are in geosynchronous orbit. So what is happening? We are trying to replace some of them. So NVS-02 is nothing but the second replacement of one of the satellites. Okay, not that important. Then just remember X6.3, this is nothing but a solar flare. X6.3. Okay. So Aditya L1 mission, the our India's mission, placed in the Lagrange 1, figured out this particular thing. First ever image of solar flare kernel in the lower solar atmosphere using the particular telescope. So just remember X6.3. Then Gaia mission, very important. This is not by NASA, this is by Europe. So what this will do, this will map the, or this will make a 3D map of Milky Way galaxy. ठीक है. Then Euclid Space Telescope is again by Europe. So EU Europe. So it studies dark matter and dark energy. Space telescope है. So just add it to the notes of your telescopes only, the previous notes. ठीक है. Biomass mission by rope not important, पढ़ लेना अगर पढ़ना है तो. Last thing I want you to read is this sunbird. What is sunbird? It is a fusion powered rocket. If you remember my science and tech classes, बेटा fusion fission में I told you the difference. Fusion हो रहा है, ठीक है. Just recall everything, you will be in better condition. Sunbird is nothing but a fusion powered rocket. Okay. अब किसने बनाया नहीं बनाया इंपॉर्टेंट नहीं है, बट सिंस फ्यूजन पावर्ड है ना, दिस इज समथिंग विच इज यूनिक. ओके, ये एक बार देख लेना. एक्चुअली दिस वाज वेरी मच इन न्यूज. ठीक है, कुछ एस्ट्रोनॉट्स अभी आईएसएस में फंस गए थे, इंटरनेशनल स्पेस स्टेशन में. तो व्हाट इज द इम्पैक्ट ऑफ द दैट्स से द ग्रेविटी लेस एटमॉस्फेयर ऑफ आईएसएस ऑन द एस्ट्रोनॉट इज समथिंग विच यू हैव टू रीड हियर. ये इंपॉर्टेंट है, इसको पढ़ के जाना प्लीज. स्पेस ट्रेवल एंड एस्ट्रोनॉट साइड. मैं 1 मिनट पॉज ले रहा हूँ, पढ़ ही लो. So it can lead to DNA damage, cancer risk. So whenever they are in space, astronauts, it lead to bone density loss. ठीक है. That is it. If you want to read anything else in this like PDF, please read. I will drop this in your Telegram channels. Thank you. Have a great day.